Answer key for homework 1D, conversion factors and density. In question 1, you need to find the volume of 75.0 grams of a liquid which has a density of 0.820 grams per milliliter. So this is a density problem. So it would make sense to begin the setup with the formula. Density is mass divided by volume. We'll use the density formula as a template. The density of the liquid is 0.82 grams per milliliter. The mass is given as 75.0 grams, and we need to solve for the volume. I'm going to set this one up as a ratio, and I'm going to solve by multiplying the cross products, starting with the cross product that has only numbers. I will multiply 75 grams times 1 and find out what this cross product is equal to. And then I'll take the other cross product and divide by any number that's in the cross product that contains the variable. So calculating for the volume on my calculator is 91.461463. Looks like a repeating decimal. That probably continues to go on. And I'm going to round this to the 3 significant figures because each one of these values has 3 significant figures. If one of these had 2 significant figures, I would round to 2. So I'm going to take the first 3 significant figures, use this 6 as a rounder, and my volume is going to be equal to 91.5, and grams will cancel. My unit will be the only thing that's left, milliliters. So for this problem, it solves out to be 91.5 milliliters. So question number 2 has a typo. We're given the density of aluminum as 2.70 grams per centimeter cubed. I believe on the original worksheets that were printed for the packet, it says the density of gold is 2.70 grams per centimeter cubed. That's not correct. Gold has a higher density. It's like 19.3. So just make sure you correct this for number 2 before you try working this problem. So if they give us the density of aluminum as 2.70 grams per centimeter cubed, we need to find the volume of a 60.0 piece of aluminum. This is another density problem. So we're going to start at the same place. We're going to begin by writing the formula. Density is mass over volume. We're going to use the formula as a template. We're going to find the different pieces of information. So the density of this is 2.70 grams per centimeter cubed. That's the density. Now aluminum is 60.0 milliliters. Well, actually, it probably would be centimeter cubed. We're going to have to fix this in a future form as well. So the volume, find the volume of a 60.0 centimeter cube piece of aluminum. And once again, we're going to solve for volume. So it's almost exactly the same as the problem right above it. We're going to take the cross products that have the numbers, multiply them through, and we're going to divide by the cross products that contain the variable. So my answer is volume is equal to 22.2 centimeter cubed. And that's how you take care of question number 2. In this question, we first have to find the volume. So I'm going to use the volume formula. And that's going to be length times width times height. And this is a perfect cube. So each is 3.00 centimeters. Now make sure you have all the significant figures when you run this one through. So don't just take 3 and multiply it through as you would. Make sure you have 3.00. So I'm going to use the volume formula as a template to calculate volume. For length, I'm going to use 3.00 centimeter. For width, I'm going to do the same, 3.00 centimeter. For width, 3.00 centimeter. So 3 times 3 is 9, and 9 times 3 is 27. And we're going to round this number to 3 sig figs, 27 centimeters. We're going to round this to 3 sig figs, 27.0 centimeters. And centimeter times centimeter times centimeter is centimeter cubed. So the volume part is 27.0 centimeter cubed. Now the second part of this particular problem is to find the mass of the cube. Now we just determined what the volume would be by multiplying and solving for the volume. So we're going to use the density formula. Okay, density is equal to mass over volume. And the density of gold, which we can look up in our No packet on the internet or any other reliable source, is 19.3 grams per centimeter cubed. We know what the volume is. It's 27.0 centimeter cubed. And we're going to solve for the mass. The missing variable is the mass. So I'm going to start my calculation by multiplying 19.3 times 27.0. But my answer is 521, and the units that cancel are centimeters cubed, and the unit that's left with is grams. So that's how you answer question number 3. Number 4, how many seconds are in 1 week? In question number 4, we have to calculate the number of seconds in 1 week. All right, so I'm going to begin here with 1 week. Now this, because of the way it's written as the name 1, this is going to be an exact number. All right, there's no choice in the matter. It's not a measurement. 1 week, I'm going to make that singular, has 7 days. And I'm just going to progress across the conversion factor in a similar way. So 1 day is equal to 24 hours. That's a known equality. We'll use that as our conversion. 1 hour has 60 minutes. 1 minute has 60 seconds. All right, so there's my setup. And if I double check the canceling, weeks cancel here, days will cancel there, hours cancel here, minutes cancel here, and we're left with, as the only unit, is seconds. So that answers the questions. How many seconds are there in 1 week? I'm going to begin the calculation in this way. I'm going to start with 1 week, multiply by the number of days, 7 days, multiply by 7, multiply by 24, multiply by 60, and multiply by 60 again. Remember, anything that's in the numerator you multiply by, anything in the denominator, the bottom part of the fraction, you divide by. So it'd be 1 times 7, of course, is 7. And then times 24, that's 168. Then we're going to multiply by 60, and we're going to multiply by 60 again. Now, my calculator answer is 604,800, and that'll be seconds, rounding. All right, so I'm going to go through and I'm going to identify anything that's an exact number, and we're not going to consider exact numbers when we do our rounding. So 1 minute is 60 seconds. That's an exact number. There's no doubt every minute has 60 seconds. 1 hour has 60 minutes. That's also an exact number. That's based on a definition. We're defining the day as having 24 hours, but we're going to use that as a definition. We're going to consider that to be an exact number. 7 days in a week, we're defining it this way. And then 1 week, we already said, was going to be an exact number. So every part of our calculation is an exact number, which means that our answer, 604,800 seconds, is also an exact number. So the answer for number 4 is 604,800 seconds. In question 5, you're asked to convert the gas mileage from miles per gallon into kilometers per liter. And 3 conversion factors are given. 1 mile is equal to 1.61 kilometers. 1 liter is approximately 1.06 quarts. And 1 gallon is equal to 4 quarts. Okay, number 5 is another conversion. We're going to use equalities. There are 3 equalities that are given in the problem. And we're going to use those equalities to make the conversion from 32.0 miles per gallon. We're going to change it to kilometers per liter. So I'm going to start. Now remember, this is a rate. And since conversion factors are fractions, I'm going to do my best to make sure that this 32.0 miles per gallon looks like a fraction. It'll be easier to see how things cancel if we set it up this way. Okay, so I'll use the first conversion. I'll use the first equality as the basis for the conversion factor. 1 mile is 1.61 kilometer. I'm going to put the 1 mile on the bottom and the 1.61 kilometer on the top. I'm going to make sure gallon is on top now so that it cleanly cancels with the gallon denominator that's in my original rate. So I'm going to say 1 gallon is equal to 4 quarts, and then I'll use the second equality. 1 quart is 1.06 liters. Now, if I double check, gallons will cancel here, quarts will cancel here. So gallons is canceled, quart is canceled. And the only thing that's left is the unit that I want. I want kilometers per liter. So I'll start with 32.0, and I'm going to multiply by 1.61. I'm going to divide by 4. 4 is in the denominator. And then I'm going to divide by 1.06. My answer on my calculator is 12.1509343. As far as rounding is concerned, 1.61 has 3 sig figs. Remember, this is an English to metric conversion, so it's not truly a definition. This one is an exact number because 1 gallon is defined as having 4 quart, and this one has 3 sig figs. In exactly 1 quart, there's approximately 1.06 liter. So it looks like my final answer should be rounded to 3 significant figures. And my final answer is 12.2 kilometers per liter. In question 6, how many 8-hour days are needed to earn $300 if your pay is $6.25 per hour? In this problem, I want to find out how long it would take me in terms of work days to earn $300 if my rate of pay is $6.25 per hour. So I'm going to begin with $300. So if it's $300 is what I would like to make, and I can make $6.25 in 1 hour, and there are 8 hours in 1 workday. There are 6 8-hour workdays needed to earn the $300. Number 7, how long will it take to move 240 bricks if you can haul 30 bricks at a time and a round trip takes 10 minutes? In this problem, it asks for how long it will take to move 240 bricks. Now that's going to be where I'm going to start. And then the rest of these things are actually conversions. So you can take 30 bricks equals 1 trip, and then this is the second equality that's implied in the problem. 1 trip equals 10 minutes. All right, so I'm going to set this one up. 240 bricks is what I would like to move. I can haul 30 bricks in 1 trip, and 1 trip takes 10 minutes. All right, so this one's set up correctly. This makes logical sense. Everything will cancel. It's set up correctly. Bricks will cancel, trips will cancel. My answer is going to come out in this calculation in terms of minutes. All right, so I'll put it in the calculator. 240 bricks divided by 30, and then times 10. So that's how you take care of number 7. Number 8, if you could earn money at the rate of $2 every second, how many days would it take for you to earn $1 billion? This one's actually a pretty easy question to do. We're going to identify the conversion factors. 1 second equals $2. And I want to find out how long it would take to earn $1 billion. And remember, when 1 is written out like this, that means exact number. So we're going to take $1 billion, and I'm going to write it in scientific notation, 1 times 10 to the 9th dollars. And I'm going to use this given conversion factor, $2 in 1 second. Now from here, it's going to be just known conversion factors. So 60 seconds is 1 minute, 60 minutes is 1 hour, and we want it in days. So 24 hours, 1 day. All right, so there's our setup. From this setup, all I need to do is the same thing I did for every other problem. I'm just going to go from left to right, take my calculator, and calculate this. And I'm going to put 1 times 10 to the 9th in my calculator. I'm going to use the exponent entry key. Okay, I'm going to divide by 2. I'm going to divide by 60. I'm going to divide by 60 again. And I'm going to divide by 24. And the number I end up with, 5.7870. I'm going to put all the numbers down, 37037, and that's where it stops. Okay, now I did notice when I put this up here that it didn't bring down all the significant figures. Everything here is an exact number. These are all based on definitions, and this is an exact number because of the way it's written in the problem. So the only source of significant figures is the $2. And that has 3 significant figures, so I'm going to round this to 3 sig figs. And my answer will turn out to be 5.7
9 times 10 to the third days.
Number 9. A bullet from a rifle is moving at a rate of 2,500 feet per second. Convert that speed to miles per hour.
2,500 feet per second. All right, so we have two different parts. We have to take care of the numerator. Feet has to be changed to miles, and the other part, seconds, has to be changed to hours. So those are the two things we're going to have to do. All right, so I need to change feet to miles. Now, usually I put this in, 1 mile equals 5,280 feet. This has to be added in to the next year. When I update this, that needs to be added as a conversion. Okay, back to this. Using that conversion factor, 1 mile is equal to 5,280 feet, and that'll take care of the first conversion. So I have feet to miles, and miles is where I need to end up, so that is good. Now, the next part of this, I'm going to take seconds, and I have to change it into hours. So these are just the known conversions. 60 seconds is 1 minute. 60 minutes is 1 hour, and that's all I have to do. All right, so now we have it in terms of, we do our canceling. Miles is actually what I want. Seconds will cancel, minutes will cancel, and we are left with our unit, miles per hour. All right, so the only thing that didn't cancel is the unit that answers the question, essentially. All right, so I just have to put this into my calculator. So I get 1,704.5454. This is a repeating decimal. It's going to go on forever. So the definitions are definitely exact numbers. This is an English to English. I'm going to assume that's an exact number too. So the only measured number is the original measurement itself. When you round a number like 1,704 to two significant figures, we don't get back to the original decimal point. So we're going to put in some trailing zeros to make sure the magnitude of the number stays where it belongs. 1,704.5454, repeating decimal, would round to 1,700. So the unit for this would be miles per hour. And that's how you do this one.
Number 10. The price of milk is $2.98 per gallon. What is the price in cents per liter?
1 gallon equals $2.98. 1 gallon of milk. And we want to change that from dollars per gallon to cents per liter. So we're going to take it's another rate, $2.98 per gallon. So we're going to change dollars, $1, is 100 cents. That one conversion will take care of that. And then to go from gallons, now I'm going to go back and I'm going to bring down some conversion factors that we used in question number 5. So in question number 5, we used some conversions that will help us in this one. I can change gallons to quarts. So 1 gallon is 4 quarts, and 1.06 quart is 1 liter. Okay, run this through the calculator, and we get a final value of 78.97. Now that's on the calculator. So we should round our number to 3 significant figures. So the final answer, 1, 2, 3 sig figs, that'll be the rounder, will be 79.0 cents per liter. Okay, and that's how you do number 10.
Number 11. Convert 55 miles per hour to meters per second. So on this one we have another rate. We're going to convert 55 miles per hour to meters per second. This is a pretty common conversion as well. So we're going to start with 55 miles in 1 hour. We're going to make sure that the rate is set up to look like a fraction so that our conversion factors, it'll be real clear which ones are canceling, which units are canceling, and which ones are not. So in question number 5, we have some conversion factors that were mentioned which will help us here. Specifically this one, 1 mile is equal to 1.61 kilometers. So I'm going to use that as my conversion. 1 mile is 1.61 kilometers. So miles is canceling and I'm in kilometers. So of course kilo is the other equality that we're going to be using. 1 kilo, kilo anything, it's a prefix, means 1,000 times larger. So 1 kilometer has 1,000 meters. 1 kilometer, 1,000 meter. 1 hour is 60 minutes. 1 minute is 60 seconds. So that is your conversion. This one was actually in our note packet, if I recall. The number was 24.597, and then we get repeating decimals. We're going to go through and mark everything that's an exact value, things that have no discrepancies. We'll just mark them as exact number. Now, this one isn't really truly a definition. So if I had exactly 1 mile, it would measure out to be approximately 1.61 kilometers. But that doesn't matter because 55 only has 2 significant figures. So we'll take first 2 numbers in our calculated answer, and we'll use the 5 as a rounder. And we'll round 2 significant figures, 25 meters per second. And that's how you do number 11.
A golf ball weighs 4.00 ounces. How many golf balls weigh 2.50 tons?
Okay, on number 12, we do have some conversions that we're going to be dealing with. They gave us 2 equalities. 1 ton is equal to 2,000 pounds, and 1 pound is equal to 16 ounces. And we want to find out how many golf balls are in 2.50 tons. So I'm going to start with 2.50 tons. It's not a conversion, right? Everything else in this is actually an equality. And there's actually one more equality right here. 1 golf ball weighs 4 ounces. So if we have 1 ton, that's 2,000 pounds. We have the second conversion, 1 pound is 16 ounces. And then the pounds will cancel. And then finally, this equality comes from the implied equality from the question itself. If we had 1 golf ball, that would be 4.00 ounces. Everything cancels, but now we have only golf balls. So all I have to do is run that through my calculator, 2.50 times 2,000 times 16. I like to hit the equal after I do every one of these conversions. My answer is 20,000 years. So this is a definition. So we'll consider this to be an exact number. This is a definition as well. That's in the same system, a ton in pounds. And then finally, this weight of a golf ball seems to be like a measurement. So it's approximately, 1 golf ball is approximately, or even worse, on average, a golf ball is 4.00 ounces. This definitely has some inaccuracies. So we're allowed to take the first 3 significant figures. This problem, for rounding, it has some unique issues. Like, for example, if I wanted to show 3 significant figures with 20,000 as an ordinary number, without the decimal, it only has 1 sig fig. So that's no good. But with the decimal, it has 5 sig figs. So it seems like there's no way, to really express the 3 sig figs that are truly a part of this measurement. You get around that is through scientific notation. Now I have my answer written in the proper number of significant figures. Sometimes this will happen where you just cannot express your answer to the right number of significant figures as an ordinary number. All right, well, that's how you do number 12, and we're going to go on to number 13.
A 12.0 ounce can of Coke costs 50 cents. What is the cost in dollars to buy 125 kilograms of Coke?
Okay, so in number 13, we have some new equalities. We have 1 pound is equal to 4.54 grams. So implied from the problem, 1 can is 12.0 ounces. And 1 can equals 50 cents. So we want to find out what would be the cost in dollars of 125 kilograms of Coke. So we're going to start with 125 kilograms of Coca-Cola. And I'm going to use the metric prefix as a conversion. 1 kilogram is 1,000 grams. And now I can use this conversion. 1 pound is 454 grams. Then I'll use this conversion. The order of the conversions, it's every problem is unique. You have to arrive at your logical sequence as you go through. But you have to make sure that as you're walking through, kilograms cancels, grams will cancel, pounds will cancel, and now we have it in terms of ounces. I suppose I could say that 12 ounces is equal to 50 cents. And I could combine these two ideas of conversion factors into one. But for sake of keeping this as simple as possible, I'm going to say that 1 can is 12 ounces. And then 1 can is 50 cents. There's a setup. From here, it's literally an arithmetic problem. If you're confident in your setup, you should be confident in your answer. 125 kilograms times 1,000 grams, divide by 454 grams, times 16 ounces, divide by 12 ounces, multiply by 50 cents. And I came up with as an answer, so this is how many cents there would be. All right, so my rounding on this one. Let's get rid of the things that are exact numbers because we're not going to consider those when this one probably wouldn't be an exact because it's a metric to English. So that would have 3 sig figs. This one's a English to English, so that would be an exact number. 1 can is 12 ounces. That's a measurement, so that's going to be 2 sig figs. And this would also be, well, no, I think this one, let's get rid of that. I take that back. 1 can, there's no question. If you show up to the store with 49 cents, you are out of luck, right? So that's going to be an exact number too. We should round to the 2 sig figs that are in 12 ounces. This would be 18,000 cents. 18,000 cents, if somebody asked you how much something cost and you gave it in terms of cents, that probably wouldn't go over very well. So I'm going to take this number right here. I'm going to take this value, 18,000 cents, and I'm just going to apply one more conversion because the answer in cents is technically right, but just practically wrong, So $1, I'm going to put this in terms of dollars. So $1 is 100 cents. So if I take this and divide it out, 18,000 cents, divide by 100, and my answer is going to be $180, correctly rounded to 2 sig figs. Okay, and that's how you do number 13.